today it's our sixth video on hashing. It's our sixth video on hashing where we'll discuss rehashing. So what prior to this video we have discussed in first video introduction of hashing. So what I'm trying to tell you is you kindly watch these sequence of videos, then it will become easy for you to understand everything. So in first video we have discussed intro of hashing, where we have discussed many things, that is something about hash table, something about hash function, something about collision. In second video we have discussed in detail hash functions. We have discussed hash function, and where we have discussed three hash function. One was division method, one was mid square method, and one was division folding method. Fine. So in third video, what we discussed in third video, we discussed collision resolution technique. We discussed collision resolution techniques. And in collision resolution technique in third video, we have discussed linear probing. In fourth video, we have again discussed collision resolution technique, and there we have discussed quadratic probing, and we have discussed double hashing. And in fifth video again we have discussed collision resolution technique, but where we used another method called separate chaining. So we have already discussed all these things, and now in today's sixth video we'll discuss rehashing. So hope you have seen all those videos. If you have yet not seen, kindly watch these video and then come to the sixth video. Let's start with rehashing. So what is rehashing? If now before reading all this, let me give you a very good example of your own home. Suppose you have a refrigerator in your home. Which is of 165 liter. Now actually what happens? Suppose the family member in your home increases. First of all, there were only 3 members in your family. At that moment you were finding this as a sufficient, storage was sufficient. But suppose 3 more members joined your family. Now you are total 6 members. So this refrigerator is started creating a problem. What you will do? You have to replace this refrigerator, because this is actually not helping you to store all the items. So what you will do? You will always try to buy a refrigerator of size double of it, no, because now you have some more members. So what you will do? You will try to have a refrigerator of some double size of it. Suppose I am taking an example of 315 liters, 300 as 330 liters, now double size. So what actually you do? You throw all the items which were stored here? No, you never throw these items. What you do, before selling this refrigerator, now you will sell this refrigerator. So before selling the refrigerator, you start storing element of these element or products of these refrigerator into a new refrigerator, and in new space you put new values. Fine. So this is what rehashing is all about. In rehashing, what you do actually, in rehashing you do what? If your hash table becomes full, no, I'm reading now. If any state the hash table become nearly full, the running time operation of it will start taking too much time, definitely, because if my refrigerator or hash table is full, and if I'll keep on storing or if I'll keep on searching, it will take a time. They're complex, because I know the complexity of hashing is order of 1. But if my hash table started no started no what to use that word, I must say that becoming full, no. So what you will do? Our complexity will start increasing. So in that case, insert operation may fail. In such situation, the best possible solution is to create a new hash table of double size. Now it's request, as I told you, to buy a refrigerator of double size. Scan the original hash table, that is scan the old refrigerator, compute the new hash value, and insert into the new refrigerator, new hash table. No, you will not throw the value of old hash table. You will compute it again and store it in the new hash table. Free the memory occupied by original hash table. Now you will sell your old refrigerator. So you will free the hash table, previous smaller hash table. Fine. So this is what rehashing is all about. If you see the figure, you can clearly see previously, this is my old refrigerator where I was having 15 location. But now I've purchased new refrigerator of size 30. So on each value we apply again rehashing, rehash every value and find some new location and insert it new values and old values also, fine. So now comes a very important load factor. What is load factor? So till now I have not discussed, now I will discuss. So the load factor in hash map is basically a measure that decide when exactly to increase the size of hash map to maintain same time complexity of order of 1. Now, as I gave you example, when there were 3 members, you was not finding a necessity to change your refrigerator. When did you find it? When did you find it that you have to buy a new refrigerator? When some more members started coming or joining your family. In a similar fashion, just because of load factor, it is decided that when to buy or when to increase the size of hash table, because I have to maintain the complexity of order of 1. That is only the benefit of hashing. Otherwise, what is the use of hashing? No. So what is load factor? Load factor is m by n. Load factor is m by n, where n is the total size of hash table, n is the total size of hash table, and m is the preferred number of entries, and m are the entries. That is, if my hash table is of size 100 and the entries are suppose 78. So if this load factor, I'm giving you example, if this load factor grows above 75%, this means now danger start. If danger start, I have to start thinking of buying new refrigerator, because any day my refrigerator can say, yes sir, I'm not able to hold any more item now. In a similar fashion, just because of load factor, I decide when to increase my hash table, fine. Okay, which can be inserted before an increment of the size. This is what I already discussed. If you are going to store so I'll not read all those stuff now. So this was, I gave you a very good example of refrigerator. So hope you will read the remaining stuff after this.